Okay, here comes the part that I love. I predict that we will be inviting Audrey in the years ahead for her to share with us her accomplishments. And then we can all proudly say, we knew her when. For 32 years, I have presented about 256 young, talented hams at the Dayton Hamvention Youth Forum. And having taught about 900 students a year for 30 years, meaning about 25,000 students, a youngster has to be pretty special to impress me. And that's who we have here. Audrey McElroy, KM4BUN, extra class license holder. I encourage you to read her very impressive bio. But I will tell you now that she is a senior at the STEM Academy who plans on attending university and pursuing a degree in electrical and computer engineering while continuing to work with amateur radio to provide hands-on practice for her academics. Audrey is the first recipient of the RCA Young Achiever Scholarship and has had the opportunity to present her experimentation at several conferences, such as the American Institute of Aeronautics and Aerospace, as well as several amateur radio virtual podcast events to a global audience. So it is my extreme pleasure to introduce Audrey, who will speak about Around the World 4.5 Times, an empirical examination of HF propagation from an orbiting high altitude balloon. Audrey, it's all yours.
Hi, everybody. Thank you, Carol, for the wonderful introduction, and thank you to RCA for having me here today. I know I'm only a high school student, but I'm really excited to share with you guys a little bit what have I been doing. The title sounds really fancy, but in I guess terms out of like a high school would say, essentially I'm going to be telling you guys a little bit about my experimentation with high altitude balloons and the things I've been able to do with amateur radio. So it's a more interesting hands-on use of the principles we all know and love. So let's see here. So yeah. So like I just said, I'll be detailing a little bit about my experiment, what it was, and how I prepared for it and how it went, and talking a little bit about how some of the interesting results in HF propagation that I found in the process of doing that. So I'll be talking about, first of all, what is this? So I'm going to be talking about the process of the hardware and software I used to create basically, it was a flight of a balloon that went up to about 13 kilometers. There was a balloon and there was a tracking device, obviously. And yeah, so hardware items I used was an SBS-13 balloon. It's a really fancy name for a balloon that orbits at about 13 kilometers when built correctly. A sky tracker provided by, and I helped build with a NASA engineer of ours, WB8ELK, his name is Will Brown, he's really cool. A lightweight 20-meter dipole antenna, of course, and software used was Whisper and Ethernet. So essentially, what was this? So that's the balloon we used for this. And the whole design of this is we have that balloon, and then below it we have our sky tracker hanging, which I'll have a picture of in just a second. So that's our balloon. And I'm sure you all have seen the balloons that are launched by the National Weather Service and all of that. And they're the huge latex balloons. And that's usually what is used. Those go up to about 100,000 feet and they pop and come back down. These are completely different. These balloons are meant to go for long term, meaning days, months, years possibly. So that's why this balloon looks the way it does. Kind of looks like a trash bag. It's a little weird, but essentially that's what we use as our balloon. As you can see, of course, it is not filled up a lot because we go back to the high school chemistry class. We all know our gas laws, so we have to inflate it. We only inflate just a little bit because we know as we go up in the atmosphere, the pressure is going to drop, the temperature is going to drop. So the balloon helps to expand, so we have to go ahead and we have to account for that. So it'll have a float altitude about 13 kilometers, if it's filled correctly. This is a much bigger version, as you can tell. of the ones that are used by NASA and those big organizations. Obviously, I don't have an airplane hangar to fill up one of these balloons, but that's, they're able to do that. So obviously it's just like any other balloon. We have to derive lift and everything. So using that fun physics, we have to determine how much helium is going to go into here to get this much lift in the atmosphere. Because obviously we wanted the balloon to go up we want it to ascend nicely, and we want it to sit at an altitude that's going to be good in terms of weather and other things. I'll talk about that in just a second. But yeah, so that's what a fully inflated one would look like for NASA. A little different than that, but hey, I'm a high school student. It's the best I can do for now. That's what a fully inflated one will look like. Obviously, gas laws, again, it'll expand. So it's a very interesting thing. I wish I could see what mine looked like when it was up there, but yeah, it was really cool. So how did I prepare for this? It was a lot of work, I'll be honest. This is what the balloon looks like when it's not filled up. And don't worry, I'll get to the ham radio part. I just like to talk about the whole process a little bit. So this is the balloon uninflated. We have to tape it down because it's kind of it's a really oddly shaped balloon, as you can tell. And I'm filling it up in my basement, so I don't exactly have all that room. So I have to tape it down, and it's a big deal. So there I am filling it up, and as you can tell, I have a scale and a weight, and it's a very scientific process. It's what I have, and it ended up working out pretty well, as you'll see in a little bit. So I have a scale right there, and I have a 100-gram weight attached to that. And what I'm essentially doing is I'm filling up the balloon and trying to get just the amount of rate of lift in the balloon, enough so that we can carry our payload, which we'll see in a second, and also with a few grams of free lift so that we're actually able to ascend. So yeah, and there is the exact amount of free lift I wanted to get, 22.3 grams, which is about right, because our payload itself is about 13 to 14 grams. So we just have a few grams really of free lift, which means it's going to ascend very, very slowly. So that gets into the point of where we launch this, and that just ends up being usually a field or something. Very little positive lift means that any little bit of wind is going to cause it to go right into a tree. We could be in an empty field, and if I launched it, it would go into that one tree. It's just how it is. But yeah, so getting that right amount of lift is very crucial. We want to ascend to a good point. We don't want to put too much helium in there, because at that point, it's going to start to hover above that 13-kilometer mark, and we don't want it there. And of course, if we underfill, we're going to be below that 13-kilometer mark, which can put us at risk for storms, which I'll talk about in a second. So specifically, we're talking about one balloon launch. I've done probably 12 to 13 of these launches so far in the past 2 years. Most of them, I will be honest, it was a trial and error process for me. I actually used Mylar balloons for the majority of those because they were cheaper and I didn't have too much worry about them. But the majority of them, what would happen is they would go up, and I live here in Georgia, so I'm in North Georgia, and so I would go up, they would go up, and they would get pushed down to the coast, the southeast coast of Georgia, which is Savannah, and pretty much get tumbled up there in the winds off the coast and would land in the Atlantic Ocean, is what I assumed, because I would watch on APRS transmitting, and I'd see the altitude go down and stop, and I assumed what had happened. So that was sad, but on this launch, it was a very unique moment for me. I wasn't thinking we were going to be able to launch it all that weekend because it was predicted to be very windy. And I was taking the trash out, as one does as a teenager in the house. And I noticed it was very calm outside. I was like, this could be our chance. And so I got our balloon, filled up this balloon at 11:30, and I ran outside, and I was like, we're going to launch it. And why was this weird? It was weird because I'd never done a nighttime launch. I didn't know what would happen. The winds between daytime and nighttime are very different because of heating the earth, where we are in Georgia. And so I was very curious to see what was going to happen. So I launched the balloon very hesitantly. Why was I very hesitant? Like I was just saying, I was very scared about where it was going to go. And it went up into the nighttime sky, and as you'll see in a second, it's solar powered. Our tracker's solar powered, so of course I'm not going to be able to see where it is. But that's our payload, by the way. It's our little solar powered. It's very light, like I said, it's about 13 grams. Barely weighs anything. There's obviously no battery in there. We don't have the weight for that, so it's a super capacitor. And what this does is it's taking great telemetry. So it's taking GPS, it's taking wind speed, it's taking voltage coming in with the solar panels, and it's taking altitude, of course. And so what is that happening? What is happening with that? We have a 20-meter dipole, it was interesting because there was me holding it, but what you don't see is my mom all the way down the street holding the other end of it, because it was quite a long chain. We had that halfway through the 20-meter dipole. So essentially what's happening is that information is being pushed out on the 20-meter band, obviously, to WSPR, Joe Taylor's WSPR, which is amazing, by the way. Weak signal propagation reporter. It's very nice. And of course, because it's HF, it's a lot nicer than using just APRS, which works on 2 meters, because that's VHF, UHF, line of sight. And there's obviously not eye gates everywhere in the world, so it's very spotty in that term, in that sense. But 20 meters was great for this. And so that's what it looks like. Yeah, oh, there's my mom holding it. She's holding the other end of it. It's very late at night. And that's a video, I won't play it, but in short terms, it's me very hesitantly holding the balloon. My mom's counting down, and I'm just like, oh, I'm never gonna let this go. And so, like I just said a second ago, we float these at 13 kilometers. I was very hesitant because it was gonna get stuck in a storm again, but it didn't. But we float these at 13 kilometers to try to avoid those storms. About 95% of the storms are gonna fall under that 13 kilometer mark. Yes, there are gonna be super storms that sometimes fall in the area where we're floating, and that does happen, but for a majority of the storms, they stay down. So a little bit about WSPR. WSPR, like I said, it was great in this. I'm really happy I chose this balloon. I'll tell you why. So the Sky Tracker transmits every 4 minutes, and obviously weak signal propagation reporter, we were like 20 milliwatts, which is barely anything, but it was amazing how we were able to see where we were being picked up throughout the world. And it was especially impressive because we're 13 kilometers above the Earth using that halfway 20-meter dipole antenna, and people all around the world were hearing us. We had an amazing footprint, and that's why I wanted to talk a little bit about HF propagation here. It was just amazing. You could see, I have a great map in a second, you'll get to see who was picking us up, but essentially this is what it looked like on the other end of WSPR transmitting. This was probably before it was launched. And so you can see how that was kind of set up. There's our Sky Tracker. So here is one of the, if you think this map's impressive, just wait. That is our balloon up there in the left corner, came for ZIA. That was the call sign of this one, came for ZIA-3. You notice that's not my call sign, that's my little brother's call sign. I will admit, he was asleep when I launched that balloon, so I don't know how much credit he gets on that, but there it is traveling. It was going through over Alaska, as you can see, and it was getting picked up all throughout the Western United States. It was amazing. You could see, obviously, here's the thing, if I've been using APRS on this one, which I've done before, it's a very similar setup, obviously minus the 20-meter halfway like dipole. I had a 2-meter antenna on there. It looks like it's basically a guitar string. It's really interesting. And so obviously if I've been using that, I probably would not have been able to pick up this location of the Sky Tracker it would have been very spotty because there's no eye gates, you know, I'm sure in the middle of Alaska, and once again, and so here I am this is our station, by the way. You see the lovely sign, beware of the ham radio operator. That's our little station, and actually what I'm doing here is I'm using my call sign, came for BUN on WSPR, to pick up came for ZA-3, the balloon, on WSPR. So it was transmitting, I'm not sure where it was, in the, probably was over the United States at this point, but as you can see, I'm actually picking it up using my own call sign. As you can see, it's a very weak signal, but it's there, and it was a great thing. It was over Texas. It was a great experiment to see not only where it was transmitting to, but seeing also how I could pick it up on my own WSPR station at home. It was pretty cool. And so it was traveling. At this point, it almost made it around the world. It was coming over the Western United States. And I was very nervous. I wanted to make it a full lap around the world. And we were tracking it every minute, hoping it was going to come over. And it eventually did. And as you can see, it's up over there. It's the northern United States, almost near New Hampshire, or New Brunswick over there. And you can see we're getting picked up by everybody. See all those call signs. And so it was really fun to see we were getting picked up throughout the world, who was seeing us. And I'm sure there was people watching us and they were like, wow, this is a lot. And it was a big deal for me because at this point we were one lap around the world. And after almost 2 years of launching these balloons and having them pretty much almost get out over the ocean and then something happening to them, which was really sad for me. Seeing this happen was a lot of fun, especially for a high school student. In my school, I'm kind of on my own on this. I don't have, teachers at school. I wish I had Carol Perry in my school. I really did. But it's kind of a thing kind of left to on my own. So being able to do this and launching it at one of the most ironic times of the day, like 11:30 at night, and having it be so successful, as you'll see in a second, it was a lot. And obviously the impressive whisper maps speak for itself. This is another picture of kind of what the path it took. So this is using a program called HabHub. So basically any how-to balloon that you launch will show up here on HabHub. It'll show you where it's been, and it'll use a program called HideSplit, which is National Weather Service, to predict where it's going to go. And so after, this was probably about 80 days into the flight, this is the path it took, and this is rendered by Google Earth. It was able to go around the globe 4.5 times, and that was a big deal. I was stunned for the fact that it just never encountered anything in the way, and it just floated. That's a better image of that. It took some interesting paths at times, as you can tell. Took a loop-de-loop up there near Greenland and Iceland. And yeah, so that's an image also in HabHub. And that's an image of HideSplit I was talking about a second ago. It's a great predictor used on HabHub, and basically it's going to tell you where it believes your balloon is going to go at 3 different altitudes. And it was correct, I'll tell you what. It did make that loop-de-loop. So, and an aspect of this that I always like to point out when I'm talking about it is the educational side of this. And I know this is something that Carol likes a lot. Using these balloons, I've been emailed by ARRL about lesson plans for this. And it's great in more than just the aspect of we're learning about HF propagation, we're learning about antennas, we're learning about balloons and gas laws and chemistry and that stuff, but you're also learning a lot about the Earth, and you're learning about, you can look at the history side of this, and you can see what really is, what this balloon is traveling over in the globe. And so we took some screen captures of where it went over in the world, and went over some very interesting places, some very fun places. It also went over some other interesting places. My brother is the expert on the Northern Warning System, but essentially these are a bunch of stations up here, the radar stations, and we noticed the balloon was traveling quite close to these stations. And we had a friend of my dad's, we reached out to him, and he at one point had worked at one of these stations. And we asked him, would this be suspicious at all? And the short answer was yes, it would be a little suspicious. Looking at the footprint of it and how it was traveling relative to the speed it was traveling at, it would be kind of suspicious, and it was transmitting on 20 meters. So, I mean, there's that, but it traveled over those quite a bit. Also traveled over the DMZ separating North Korea and South Korea 2 times, I believe. I don't know how that was I don't know how that was reacted to, but I'll answer your question in a second. But I'm sure it was very interesting. That's what that looks like, by the way. One of the radar stations. They probably thought it was really weird. I'm just saying. Yeah, so it traveled in just a few, very close to these. So yeah, that's pretty much what I have to say about that. I wanted to use the rest of this time to answer questions and talk about maybe with Carol the educational side of what this is like. It's a lot of information, so.
All right, Audrey, great job, and thank you so much for your presentation. And I'd like to thank Barney Scholl for moderating the first 3 talks. He did a very nice job, and I'd like to welcome Margaret Lyons, who is our moderator for this talk and the next 2 after Audrey. And with that, Margaret, I'm going to turn it over to you, and you can start the questions for Audrey.
All right. So one of the questions that came through in the chat was, is there any way, and are you getting any, school credit for this work that you're doing with balloons and with radio?
I wish I was. I do not, unfortunately. So at my high school, I go to Forsyth Central High School. The middle school I went to originally did have an amateur radio club. That was 12 years ago. If you go into a closet at that middle school, you'll find a bunch of radios and equipment that hasn't been used for 10 years. And so I tried to talk to people about it, but in short terms, no. I don't get credit for it at school, but my science teacher thinks it's pretty cool. So.
Oh, yeah, and it is. I noticed you said you were 2 years launching balloons and going into the Atlantic. Can you talk a little bit about what motivated that persistence to keep on and keep going, and how much longer would you have gone if this one wasn't so exciting?
Yeah, so those two years were quite difficult. We had spent a lot of time, and I thought it was my fault because I was the one filling up these balloons and doing everything and assembling and getting everything ready. And every time I would launch it, and it would have the same thing would happen. It would go out over the coast of Savannah, Georgia, and it would get knocked down. And so I feel like what gave me persistence to go on was looking at what my mentor, Bill Brown, he was telling me, just keep trying it, it'll work eventually. And he had been able to do several launches with NASA, much bigger scale launches that were successful. And I'm like, well, if he can do it, maybe I can do it too. And so I think what played a large role into it was the time at which I launched it. Because every other time I launched these balloons, it was around noon. And so the same thing would happen, the balloon would go to the same place. But when I launched it at like 11:30 at night, I noticed it went out, it took a completely different path and almost went directly east out over South Carolina and went out over the Atlantic Ocean that way. And so when I was able to do that, I thought, hey, maybe I figured something out. And so that's what keeps me going. And so now, from now on, my balloon launches, if I'm launching them here in Georgia, where I am, I will probably continue to launch them at night, just to avoid the bad weather and the storms off of the coast of Savannah, where I'm sure there are probably 5 or 6 of my sky trackers floating around in the ocean. And I'm sure people have found them and they're like, oh my goodness, what is this? So, I'm sure people have thought very interesting things about that, but yeah.
We have another question. I know in your bio you're interested in studying in electrical and computer engineering. One of the questions says, how about Penn State? And I would, speak for anything. What about the aeronautical? Are you looking at schools that have both strong aeronautical and electrical, or really focused on electrical? What's going on in a senior's mind?
Oh, a senior's mind. Well, I'll tell you a lot's going on. Yeah, so actually my dad is from Pennsylvania. He grew up in Pittsburgh. So Penn State's always been like that thing. So, I've considered Penn State a lot just because I have a lot of family there. But in terms of electrical and computer and aeronautical engineering and all that, I've always been geared towards electrical and computer engineering just because my dad, Yeah, like so my dad went to school up in Pennsylvania, and he studied electrical engineering, and so he's always been there to help me out. And I found a passion in computers, and so I look at, just because where I am, don't come for me. I look at Georgia Tech just because I'm right here. But obviously, all those schools are great, and I was just accepted last night to University of Georgia Early Action, so for engineering. So
That's very exciting. Very good.
yes.
I had a question as you went through. Which drew you in to the other? Were you first interested in the balloons and the aeronautical, or was it the radio that then drew you into the balloons? Which came first? How did that happen?
Yeah, so I got my license when I was 13. So it was the radio first for me. The history behind how I became an amateur operator is a long history. So my mom grew up in New York City, and so when they moved down to Georgia, my parents were here when 9/11 happened, and they saw how all communications went down, and they took that as a step. They took that as motivation to get their license. So both my parents are licensed. And so when I became old enough to understand what Ohm's law was and what an antenna was, I was like, okay, I think I should become licensed too. So I became licensed, and I was able to get my general a little after that, and eventually my extra a few years later. And so on that aspect, I've been a contester. I was with the Dave Coulter Memorial Youth DX Adventure a couple years ago. So we were able to go down to the island of Curacao, make a ton of contacts. It was a lot of fun, by the way. So I've been on the contesting side of it. And then when I got in contact with my mentor, Bill Brown from Alabama, he talked to me about ballooning and all that stuff. So I got initially involved in high altitude balloons, like the latex ones you see. I was able to launch one of those a couple of years ago, and my brother helped out launching one on the it's called Youth on the Air. It's local. It's an international actually group of youth amateur radio operators. And so initially I got involved in that, and then I'm like, well, I heard about this balloon that could go around the world like 5 times. So I'm like, I'm gonna try that. So started with that, obviously had that trial and error, and then a couple years later was able to actually launch one that made a successful flight. And one thing I want to talk about, I forgot to mention in my presentation, is what happened to the balloon.
Yes.
I'm sure that's a question of, so the balloon went 4.5 times around the world, but where did it end up? And I thought I had a picture there, but I didn't. But basically it ended up, it was kind of strange, I will be honest, because we passed over some interesting territorial areas in the world. It was nighttime in China when it just suddenly died. And I just woke up the next morning and it just hadn't transmitted. And I checked again for the next few days and it was gone. So I like to say it vanished under mysterious circumstances over rural China. So I'm not sure what happened to it, but 4.5 times around the world. Yeah, it was bound to go down at some point. But
we did have a question. Did you do any simulation modeling, kind of looking ahead of where you thought the path of the balloon might be? And I know I noticed it stayed in the northern hemisphere. Is that sort of part of all the wind patterns too, that it would do that?
Yeah, that's something I noticed as well. All the balloon launches that I've personally done, the ones that I've been able to see done, have stayed in the northern hemisphere, and that's a very interesting point. Yeah, I believe it's the winds. But with modeling, I used a few different programs. I looked at the data from my old launches around the same time of year, and I'm like, well, I should mimic that. I also used some software. Well, the software is a website called Windy, and I can see what they're going to estimate the winds to be, how intense they're going to be at different altitudes. So I use that as kind of a indicator when the best time is going to be to launch. And so that one weekend, I happened to see that during the daytime, the winds are going to be way too strong. If we're getting 15-mile-an-hour winds, I can't launch. It's going to go directly into a tree, because I basically live in the middle of a forest a little bit here in North Georgia. So the big poplar trees say no to that.
Right.
So yeah, I use that to kind of estimate where I think it's going to go, and that kind of helps me out a little bit.
Georgia is different. I live up here in New Jersey. Are there any regulations like you would have if you were flying a drone or a radio controlled aircraft of where you can do a launch? Although maybe you have enough property, but are there rules more generally, or you just have to watch where you live, what those kinds of rules might be?
Right. Yeah. So it's like a yes and no. So for the big latex balloons I launch, I have to get a nose to airman filed with the FAA because not for in general, because I'm not very close to Hartsfield-Jackson Airport, which is the major Atlanta airport, but I'm close enough to the point where they need that information. But because what I'm launching is basically the payload's only 13 grams and it's a balloon that's relatively small, I don't have to file anything officially. We fall under a guideline in the FAA regulations saying it's under a certain weight and a certain density that we don't have to file officially for that. But yes.
So we have a message or a note from the president of the radio club who says, really look at that Georgia Tech. It's number 5 in graduates, more women engineers than any other university. And he says there's at least 2 Georgia Tech grads who would give you a recommendation or a reference. So we have that. Yes. And then someone else says, have you considered Air Force, ROTC, and Space Force and things like that?
Yeah, I think my goal was to go to college, get a 4-year degree. I would totally be interested in going into the military though in this aspect. I think it would be a great line of work. It'd be a lot of interesting work. I'm not in ROTC in my high school, but we don't have it here. But it's something I would think about pursuing after college. Yes.
That's great.
I see a comment from one of the people from my local group on the Amateur Radio Association. Hi, Mr. Jim Farmer.
All right, we got some notes and some prediction to look at. What was the last reported altitude before it went quiet?
Ooh. Yeah, okay. So it happened to be nighttime in China when it went down, meaning it hadn't transmitted. So the last reported altitude was about 13 kilometers where it should have been. But essentially, it just didn't transmit again when it was daytime. So I assumed at some point in the night when it wasn't sending telemetry that it had gone down. So it was at a good altitude, but obviously I didn't get transmission again. So yeah, it was where it was supposed to be before it went in nighttime.
And you actually answered some of the notes I was writing down for questions as your presentation went along. So kudos for that too, being thorough in your description of what was going on. Trying to think of what other nice questions we have for you. You said you got the early acceptance at Georgia Tech. Where else have you applied?
It was early acceptance at UGA. Georgia Tech is coming soon. I will know. Just a side note, I know University of Georgia doesn't sound like that much, but it's become very competitive, UGA here. But besides Georgia Tech and UGA, I'm looking at Purdue. I am looking at Penn State. I'll be visiting Purdue next week. I'm very excited about that. Looking at Illinois, Urbana-Champaign, so schools like that. Yeah.
So yeah, I'm a Purdue grad, so I that's why I asked about the aerospace question too, because they have strong in both, which you seem to have much. So I'm looking at, okay, so we're hearing that there was an Air India plane that had to make an emergency landing after a balloon used to do weather got into one of its engines. Just a long comment. So I don't know if there's a question there.
So
I think
maybe I can ask a question here. Audrey, what have you done in the area of lining up scholarships?
Yes. So of course I have the wonderful RCA Young Achievers Scholarship I'm very grateful to receive. Beyond that, I am in line for the Zell Miller Scholarship here in Georgia. And I'm also in the process of sending in my ARRL application for scholarships. So I should have that in within the next week or so.
Yes. Get that,
Put in the
get that
plug
in.
for Society of Women Engineers. They have a bevy of freshman scholarships. It's an online app. Yes.
We'll do that. Yes.
Society of Women Engineers. You Google it. Yeah. And we had a note from our Professor Colonel saying, West Point full scholarship.
West Point has been emailing me to no end. I don't know why, but they're like, Audrey, please. I don't know. West Point's a great school. Yeah, this is what happens as a senior. You're like, oh yeah, I'm a senior in high school. And the first question beyond that is, so where are you going to college?
Yeah.
So,
Definitely.
Excited.
Someone else says, don't stop with Earth-based military, go for being an astronaut.
Yeah, and actually, I think someone asked why I specifically chose how-to balloons. I actually was involved with satellite stuff. So I had a satellite ground station in my backyard that I spent a long time getting together, a very long time setting up and getting perfectly aligned with SAP PC32, which is the software I used. And it was running great. I was able to make contacts. And I was able to decode slow scan TV signals from the ISS that were transmitted. And that was great. And I'll admit, I would have been more split right now between projects in how-to ballooning and in satellite work. If it hadn't been for the fact that, once again, I said I live in the woods, basically. So a few trees decided that my ground station was in their way as they fell. So unfortunately, that came to an end. But yeah, so I wasn't just involved in how-to ballooning. I also did a lot of fun projects with satellites and getting involved in that. So yeah, it just happened to be that how-to balloons was the hobby that survived Hurricane Irma. So yeah.
Right. When's your next launch planned?
Yes. So the next launch, I don't have one. Well, actually, no, I have a big one planned. So I talked about how I've also done how-to ballooning with latex balloons, like the big deal how-to balloons. I think that comment about the airplane was talking about one of those, a much bigger balloon setup. I don't launch those often, but I'm planning on launching one in the probably upcoming month or so. That'll actually have biological samples on it. So in my high school, we're required to do a capstone project. And of course, some kids decide, oh, I'm going to build a bookshelf. But I'm going to, mine's a little more it's a little more crazy. So I'll be launching a payload. Essentially, it's a big foam box. It's going to have, of course, all of our radiotelemetry stuff in there, as well as biological samples. It'll be little nematodes. They're little tiny worms. And I'm going to be sending them up to about 110,000 feet at the moment.
Wow.
What the plan is. And we're going to see, I just want to see, it's kind of like a more for fun thing. I want to see about if there's any, how it affects them, with microgravity, radiologically, I guess. So that'll be an interesting experiment. But yes, that will be a big deal launch. So.
And how long would you expect that one to be in the air, and will you track it to grab it when it lands?
Yes, so I will be tracking it. I expect it to probably be 2 hours. So I would hope that it would go up. Last time we were able to track it almost completely. Unfortunately, around 10,000 feet on its descent back down to Earth, it gave up transmitting. So that was a big deal. But I hope for this time. I'm hopeful that for this time we'll be able to track the entire time. We'll be able to recover it, because it's all great, but it's not great if you can't recover it. So that'll be an interesting project.
Presentations, I mean, this is a special one, we're recording it, but do you make like YouTube videos or things like that for, talking about any of these different exciting things that you've done, so that clubs or just random people can find you and see what you're up to?
I haven't been up to date with that, but that'd be a great idea. I've presented to local clubs and done some presentations with Carol, but beyond that, I haven't posted regularly. But I do have a YouTube channel. It's just my name, and I'm there. I do have a presentation I did for Youth on the Air about a year and a half ago. It talks about a little bit about balloons, but that's something I hope I will get into. That'd be a lot of fun.
And I'm jumping around topics as I see different questions. Your nematodes, when they go up, will they have any extra pressurization around them, or that's part of the experiment?
That's part of the experiment. We're gonna see what happens. I mean, here's the thing: an outcome is an outcome. If they all die, that's an outcome. So essentially, the way it's gonna work is the nematodes are gonna be on petri dishes. They're gonna be plastic ones that are gonna be layered with the supplements they need to live. And I'll be launching those at will be nematodes at different stages of life. So I'll be seeing what happens to them as they go up, and hopefully a few of them will be alive when I come down. But yeah, they won't be they'll just be sitting in the container. They won't be in any special chamber or anything.
So
Okay.
Audrey,
Yeah.
why don't you tell everybody where this was?
Yeah, so this was the Dave Calter Memorial DX Adventure trip. This was in Curacao, and I want to say 2019, July 2019. That's me, that's my brother, Jack came for his AA, and that's Brian Rascal, KG5HBO. He is a great CW operator. I think he does like 60 words a minute. It's insane. He's insane. But that was an amazing trip. We got to go down to a shack, and we were all able to make so many contacts. They have an amazing shack set up for us. We had that saltwater propagation going. It was nice. I think we totaled out at 6,590 contacts total, including CW and voice. So Bryant was our CW op, and Jack and I tagged in on the voice thing, because I thought, if there's anyone here that's going to do CW and get us a lot of contacts, it's going to be him. So
Great
that
job.
was a lot of fun. I've been lucky enough to have had so many experiences in so many realms of amateur radio. I've done the contesting half of it. I've done, the fun kind of weird experimentation half with ballooning and stuff. And I've also just been able to just hang out on the radio and talk to people. So amateur radio has been, an amazing, not just a hobby for me, it's kind of become a life when you're my age. So it's been amazing.
Congratulations.
Fantastic. Yeah. I think the other thing that I had made a note, and now I don't have a good place to filter it in, is Audrey, I don't know if you know, and some people listening do know, that the Radio Club of America started out, they were the Junior Aero Club. That's how they went from aero and into radio, and here we are 110 years later. So that's what I have. We have 2 minutes left. Any closing thoughts, Audrey?
Well, thank you for having me. I know I'm, just a high schooler, and I unfortunately, I hope to one day have as many degrees as you all do, but I'm very excited to go to college and everything. But I'm really, thank you for letting me come here and talk a little bit about what I've been doing and all that.
And Carol Perry, would you like to give some closing remarks before we go back to Jim?
Well, all I can say is, what is there to say after a performance like that?